Saudações siderais, estamos começando o Conexão Sideral, um programa para falar com gente bacana, gente inteligente, grandes cientistas, personalidades, e hoje vamos conversar com o professor Livio. Livio é astrofísico, trabalhou durante muitos e muitos anos no Space Telescope Science Institute, que é o órgão que gerencia e opera o telescópio espacial Hubble. Trabalhou durante muitos anos na investigação da energia escura, essa misteriosa força que está acelerando a expansão do universo. E ele escreveu vários livros de divulgação científica e está lançando agora no Brasil o seu último livro chamado Tolices Brilhantes. Aqui, ó. Tolices Brilhantes, Brilliant Blunders em inglês, é um livro que aborda grandes erros de grandes cientistas. O professor Livio escolheu 5 grandes cientistas para abordar neste livro. Então são eles: Charles Darwin, Lord Kelvin, Linus Pauling, Hoyle e Albert Einstein. Claro, Einstein não poderia faltar. E ele aponta 5 erros importantes que esses cientistas cometeram, como diz o próprio título do livro, erros brilhantes, não erros crassos, não erros estúpidos, mas erros que acabaram, apesar de estarem fundamentalmente equivocados, acabaram levando a grandes avanços na ciência. Então, no caso do Charles Darwin, o fato dele ter desenvolvido a teoria da evolução por seleção natural, uma teoria que permanece válida depois de mais de 150 anos, desenvolveu com base num conceito de hereditariedade que hoje nós sabemos que está todo errado, né? Quer dizer, ele não tinha conhecimento ainda de experimentos que estavam sendo feitos na mesma época, em meados do século XIX, pelo Gregor Mendel, que explicavam como é que era a transmissão de características hereditárias, e ele usava um conceito mais antigo ali, que presumia que as qualidades, as características hereditárias iam diluindo com o passar do tempo, e ele não percebeu que ao defender essa ideia mais antiga, essa ideia estava em flagrante contradição com a própria teoria da evolução que ele havia formulado. Claro, quando você coloca Mendel no lugar, as coisas se encaixam direitinho, mas ali ele tinha uma contradição flagrante e ele não se deu conta de que existia essa contradição na teoria, que só seria resolvida depois que foi consagrado o trabalho de Mendel com a genética. Lord Kelvin era um grande gênio da termodinâmica de meados até o fim do século XIX, e ele foi o primeiro cientista a conseguir fazer um cálculo robusto, baseado em física, da idade da Terra. E ele estimou a idade da Terra em 100 milhões de anos. E era de fato um cálculo razoável se as premissas das quais ele tivesse partido estivessem corretas. Só que essas premissas não estavam corretas. E a grande falha de Kelvin, segundo o professor Livio, foi justamente ter ignorado a possibilidade de que as premissas estivessem erradas, de que o cálculo acabasse levando a uma idade muito maior do que ele imaginava, como já defendiam os geólogos e os paleontólogos da época, e os físicos liderados por Kelvin tinham maior resistência. Mas eventualmente ficou demonstrado que realmente a premissa central usada pelo Kelvin para o cálculo, que era o fato de que a Terra, desde a sua formação, só está perdendo calor, ela não gera calor, e ao mesmo tempo de que esse calor ele se transmite do núcleo da Terra até a superfície de uma forma mais ou menos homogênea. Essas duas premissas estavam erradas, e com isso o cálculo dele estava errado, e ele foi teimosão lá de insistir que o cálculo estava certo, apesar de outros cientistas apontando que existia essa possibilidade de estar errado. Avançando para Linus Pauling. Pauling é um cientista que todo mundo que já passou pela escola, pelo ensino médio, já ouviu falar dele, grande químico, e ele teve um enorme sucesso para decifrar a alfa-hélice, a estrutura base das proteínas, né, que são as principais moléculas que realizam o metabolismo e formam a estrutura dos seres vivos. Só que ele não teve o mesmo sucesso numa tentativa posterior de decifrar o DNA. Ele partiu das mesmas ideias, mas acabou chegando a um resultado completamente esdrúxulo, que envolvia uma tripla hélice, uma molécula super complexa, e no fim das contas quem acertou na mosca na decifração da estrutura do DNA foram James Watson e Francis Crick, lá no Cavendish, lá na Inglaterra, né, em 1953. E o grande erro do Pauling foi não ter notado que aquela estrutura de tripla hélice muito louca que ele tinha proposto, na verdade, ela violava princípios flagrantes ali de química básica. E, envolvido na complexidade, ele acabou perdendo isso de vista. Passando adiante, chegamos no Fred Hoyle, outro grande, brilhante físico, responsável por nos explicar como que é possível a formação de toda a tabela periódica, todos os elementos mais pesados, a partir dos três mais simples, no coração das estrelas. Quer dizer, a teoria do Big Bang já mostrava como hidrogênio, hélio e lítio poderiam ter se formado justamente no começo do universo, mas ninguém conseguia explicar como os outros elementos eram formados. E o Fred Hoyle foi o cara que decifrou esse mecanismo e descobriu como carbono, oxigênio, ferro e por aí vai são produzidos no coração das estrelas. Só que ele também tinha uma birra com a teoria do Big Bang. Ele não gostava daquela ideia de que o universo teve um princípio, ele não achava que ela fosse bonita o suficiente. E ele desenvolveu uma teoria alternativa chamada teoria do estado estacionário, que presumia que o universo de fato estava em expansão, como era observado, mas que matéria era constantemente criada para manter as mesmas condições do universo pela eternidade afora. E o grande erro dele foi ter insistido com essa teoria, mesmo depois que as evidências apareceram de forma esmagadora em favor do Big Bang, do começo explosivo do universo. E por fim, temos Albert Einstein, que o professor Livio faz uma brincadeira. Todo mundo conhece o grande erro do Albert Einstein como ter sido o de introduzir nas suas equações da relatividade geral a famosa constante cosmológica. Isso porque ele também não tinha informações de que o universo estava em expansão e não aceitava essa ideia a priori de que o universo pudesse estar em expansão. Então ele incluiu a constante lá para manter o universo paradinho. E no final das contas, quando ficou demonstrado por Edwin Hubble que o universo de fato estava em expansão, Einstein se arrependeu amargamente da sua introdução e defendeu a partir daí a retirada da constante cosmológica das equações. E no entanto, depois de muitas décadas, a gente foi descobrir a tal da energia escura que funciona exatamente como a constante cosmológica de Einstein. Então o professor Livio faz uma afirmação que eu acho muito curiosa. Ele não diz que o grande erro de Einstein foi introduzir a constante cosmológica. O grande erro dele teria sido tirar depois a constante cosmológica, uma vez que ela já foi introduzida. Mas enfim, vamos conversar sobre isso e muito mais nos próximos minutos. Confira aí o papo que eu tive com o professor Livio. Well, first of all, Professor Livio, thank you very much for taking the time to do this interview. It's a pleasure to talk to you. And you're just now releasing your latest book here in Brazil called Brilliant Blunders, which talks about a subject that is not usually mentioned in many popular science books, which are, you know, grave mistakes by great scientists. I was wondering, what was your motivation to write about mistakes in science? Why do you feel the public has to think about this?
So there are several reasons. First, there is a small, simple reason, which is that it is kind of comforting to the rest of us to know that even the greatest minds made some serious mistakes. But this is only a small reason. The main reason has to do with the fact that the way progress in science, and indeed in actually most creative enterprises, is usually described when you learn this at school and at university, when it's presented in the media, it's always kind of presented as if it was some sort of a direct path, a direct march to the truth from A to B. And anybody who has been engaged in such enterprises knows that nothing can be further from the truth. Science progresses, you know, in a zigzag path, with many false starts, many blind alleys, many occasions where you need to go back to the starting point, and so on. So this is one of the things I wanted to convey in this book. The other thing that I wanted to convey is, you know, we like to talk about that we would like people to think outside the box. Well, you know what? When people think outside the box, many times they make mistakes. So there is a lot to be said for slow incremental progress. But every now and then you want some people to take the risk, think in unconventional ways, outside the mainstream, and because those could lead to breakthroughs. And you will notice that my book is called Brilliant Blunders. It's not called sloppy blunders. So these are not mistakes that people did because they were really sloppy or, and so on. These were mistakes that were done even with careful thinking about them. And all of the mistakes that I describe in the book eventually actually led to breakthroughs.
I see. And well, I just finished reading the book. I was very, very interesting. And also, I was wondering what made you choose your 5 scientists. Because, there are so many great scientists, and not much is said about their mistakes, but all of them make great mistakes. And you chose, I felt that it was because the topics they were working on are still hot topics today. So evolution, the age of the earth, the destiny of the universe. What was your objective while choosing the
there were a number of guiding principles. First of all, I didn't want to go too far back. You see, because, for example, let's suppose you take somebody like Aristotle, who was, there is no doubt he was a great genius, right? But, everything, and I mean everything he said in physics was wrong. So if you go too far back, you find that almost everything is a mistake. Now, this doesn't make him any less of a genius than what he was. It's just that, the background against which he worked was very different. So first of all, I didn't go too far back. I only went to the middle of the 19th century. So that was one thing. The second thing, I wanted all the scientists to be great scientists, not just, some okay scientists and so on. So I chose great scientists. And third, you just pointed this out yourself. There is a thread that connects my 5 scientists, and that is the word evolution. Evolution of life on Earth, evolution of the Earth itself, evolution of stars, and evolution of the universe as a whole. So this was another, principle that connected the 5 people that I chose.
I see. And I was wondering, I feel it was very interesting, the reasoning that you do, and trying to explain why those people made those specific mistakes. And one thing that I think is very interesting is that those 5 scientists, although they were all brilliant, they are not remembered the same. Some of them are mostly remembered because of what they got it right, and some of them are mostly remembered because of what they got wrong. And why is that? Why Hoyle, for instance, which was a genius, and Kelvin, which is a genius as well, they are remembered for all that they said that was wrong instead of what they said it was right.
Yeah, you're right. So I think partly maybe that is because in those 2 cases, I mean, both Fred Hoyle and Lord Kelvin, both of whom were really geniuses, there is no question about this, they stubbornly, continued to hold on to their things that were mistakes. They did not, like, for example, Linus Pauling, okay, his model was wrong. He recognized this a few months later and already admitted that the Watson and Crick model was better, and so on. Lord Kelvin did not accept till the day he died that he was wrong on anything. And Fred Hoyle continued to believe in, some form or another of the steady state universe, also till the day he died. So people who knew them a little bit better, like, let's say, Lord Martin Rees, who, knew Fred Hoyle personally very well, and is also a very good personal friend of mine, still has a picture of Hoyle on the wall in his office, because he regards him as a genius, yes? But people who, are more distant from these people, they like to remember the bad parts more.
Well, let's talk a little bit about each one of them because they're all very interesting characters. And let's start by the order you put them. So let's start with Darwin. And you mentioned that Darwin's mistake was, not acknowledging that the heredity scheme that was prevalent at the time was fundamentally incompatible with his theory of evolution by the means of natural selection. And I was wondering if that was really, a mistake, because he had reservations, as you say yourself in the book, if it was a mistake or an act of desperation, because, this guy was working for over 30 years on this theory, and then Alfred Russel Wallace appeared with a letter saying, well, I kind of got the same idea you have, and then he was hard-pressed to publish. So wasn't that an act of desperation instead of a real mistake?
No, not so much of desperation, because, Wallace himself later admitted many times that, yes, he had the idea of natural selection, but Darwin had by far a more complete theory of, the whole concept of evolution and so on. So, no, I don't think it was an act of desperation. He was despaired after the mistake was pointed out. And then he tried in various ways to correct for that, and he was unsuccessful in that. But originally, in spite of the fact that he was never happy with the theory of heredity that he was using, which was blending heredity, he didn't recognize immediately that, his theory could not have worked with this. And, I attribute it a little bit maybe to his weakness in mathematics, maybe, which he always admitted that he was weak in mathematics.
And one fascinating aspect of this story is that, the solution was at hand, because Gregor Mendel already had published about his experiments. Right. So it was a near miss, right?
Yes.
How often does it happen in science?
Yeah, the thing is, that I honestly don't think that, as you know, I argued in the book that Darwin never saw Mendel's paper, but my feeling is that even had he seen the paper itself, he would not have immediately grasped, the precise significance of that. And, you should note, and I mentioned this, that it actually took another 30 years for the community to even understand, the implications of Mendel's experiments. So it was a near miss, but not that near.
Was that an early symptom of the need for multidisciplinarity in science, that he didn't know the mathematical background to, to really grasp what the problem was and how to solve it?
Well, it was a little bit that, but please remember that I still consider Darwin's theory of evolution by means of natural selection is one of the most fantastic theories we have, and it is entirely non-mathematical. So I still see this as almost a miracle.
Yeah, and it's very impressive that after 150 years, it's still basically the last word on the subject. So it's very impressive. Well, moving on to your next subject, which is Lord Kelvin, and genius of thermodynamics, brilliant man. And his mistake, according to your book, is that he was unable to acknowledge the possibility that he could be mistaken. So that's a very strange mistake to do. And how do you feel that this can explain, a scientist that is supposed to think in skeptical terms, to be so enthralled with his own abilities that he can't see that he may be wrong?
Yes, I think that this perhaps has to do a little bit with age too. I mean, at the time that his mistake was exposed, he was already fairly advanced and, had a great reputation and all that. So at that point, it becomes presumably, I'm not a psychologist, but it presumably becomes harder to acknowledge one's mistakes. An important point that I want to make, and you notice this, is that in almost all books about Kelvin, you will read that his mistake was that the reason he got the time wrong is because he didn't consider radioactivity. And that is absolutely not true. I mean, as I explain in the book, it is true that he did not consider radioactivity, but this was not the reason for his mistake. I mean, the reason for his mistake was really that he neglected the possibility of convection. I mean, with his notion of no convection, even had he included radioactivity, it would not have changed much his estimate, because he couldn't mine, heat from deep enough by that. So that is actually something that is described wrongly in most places.
Yeah, but one word that comes to mind when I think of Kelvin is the word impossible. He said it a lot, and a lot of times he was wrong. He said airplanes were impossible. He was thinking, most of physics was done by the end of the 19th century. So at what point self-confidence is a bad thing for a scientist? Because he has to have some, right? Because he pursues an idea without prior knowledge if it's right or wrong. But then it comes to a point where it's too much, right?
Yeah, if you don't keep an open mind to the possibility that you're wrong, then it's already bad.
Okay. Well, and then we arrive at Linus Pauling. Again, yes. Brilliant. And the aspect I wanted to talk to you about in his mistake, which was, yes. To use a technique that worked before to decipher the structure of proteins and apply it to DNA, and then coming out with a structure that was, chemically impossible, and thinking it was right. And he thought it was right because he felt it was beautiful and it was complex enough. And you wrote about this in other books of yours, the idea of, beauty and simplicity in scientific thought. And, well, it seems like it's a balance, right? You can't have so simple that it doesn't work, but you can't have too much complexity in it, and it seems that his mistake is somewhat connected to the idea to his preconception that DNA should be more complex than what really is. Do you feel it's something like that?
Well, it's a little bit more complicated than that. I mean, at the end of the day, I think that Pauling's mistake was because he became too confident following his success with the proteins. Basically, he was the victim of his previous success. I mean, in the case of proteins, you remember that there was a problem that, he couldn't reconcile, that 5.4 angstrom, thing in the structure. And that's why he delayed publication for 13 years. But at the end, he was proven right about that, about proteins. And all those so-called problems turned out to be, details that worked out in a different way later. And so in the case of DNA, it's not that Pauling didn't know that his molecule cannot hold together chemically. I mean, this was the guy who was the master of chemical bonds, and so on. Surely he knew that. But the thing is, he was so enthusiastic about the fact that he could come up with a model at all that he thought that all those things will turn out also to be details that will be solved later. And at the end, I think what really killed him was the fact that he didn't see, of course, the X-ray diffraction images, but the fact that he didn't realize that there was much more water in the molecule than he thought. And so when he put two strands in there, he just didn't get the density right. So in order to get the density right, he inserted a third strand in there. And that, of course, was already a huge mistake. So, so he didn't have the best data. There were some things that he didn't know about. And he was so confident based on his previous success that he was sure that everything else will turn out to be just details.
By the way, I don't know how you feel about this, but I, for myself, I'm really impressed by what those guys, Pauling with the alpha helix and Watson and Crick with DNA, how could they get it so right with so little data? That kind of impresses me.
Yeah, it is very impressive. Especially, I was trained as a physicist, not as a biochemist. So when I look at those structures, I say, "What? This is the model they managed to come up with." But you see, the reason I still think that, some people ask me, they say, "I see nothing brilliant in what Pauling did because he was wrong and that's it," and so on. But the reason I still consider it brilliant is that he actually developed the method of thinking about this, which actually Watson and Crick eventually adopted. They actually thought exactly like Pauling when they found the correct model.
Yeah, and that kind of shows how, success and mistake really are hand-to-hand in science, right?
Yes, that's right.
Well, moving on with Fred Hoyle,
yes.
The guy who basically made the Big Bang Theory consistent with the universe we observe by explaining, how all of the periodic table came out of stars, and then he goes completely against it, and even with all evidence, he still manages to defend steady state.
Yes.
Going on with the theme of preconceptions, was it the problem that Hoyle thought the Big Bang universe too ugly for him to accept it and feel that, it was a more beautiful, elegant solution, the steady state theory, in spite of, evidence did not go along with it?
So I think there were two things. One was that indeed, to this very day, I will admit that the steady state model is more elegant than the Big Bang. It's a pity it turned out not to be correct, but it was so much more elegant thing. Things don't change in space, they don't change in time. It was great, But the other thing that was that caused him to continue to hang on to this was that he really couldn't convince himself to his last day that something as complex as life could actually emerge in a few billion years. He thought that one needs a way, way longer time for that, for life to emerge, through just normal physical processes. And that, because he didn't see a solution to that, he sort of had to think that the universe must have had much more time at its disposal to make life. And of course, the steady state universe gives you an infinite time. But he really couldn't believe that in a matter of a few billion years, life could emerge.
Is it something that if Darwin had thought like Hoyle, he could just discarded evolution because it was incompatible with heredity, the heredity understanding of the time?
Right. Right.
Well, and it's impressive how different was Hoyle from Einstein in this regard, because I read recently that it was uncovered that Einstein kind of flirted with a steady state model in 1931, and then when he saw it was, there was a mistake, instead of trying to get rid of the mistake, he just got rid of the model and said, I'm not going to mess with expansion again. I did it once, I won't do it twice. So
Right.
They had a different way of thinking. Einstein was more willing to give up on his views than Hoyle, for instance, and that maybe can explain why Einstein was so pervasive and was revolutionary even in fields of physics in which he didn't necessarily agree with the conclusions of the theories of the time.
Right, but at the same time, I mean, do remember that Einstein also, after removing the cosmological constant from his equations, I mean, very stubbornly persisted to putting it back again, which people like Lemaitre and so on tried to convince him that actually it has to be there, and he absolutely was against it. He had a somewhat false understanding of aesthetics of the physical theory. He couldn't stand the fact that in the equations the cosmological constant appears as an addition. You like to think that physical theories are more like, they have multiplications, that they have factors that multiply each other and not something plus something else. That doesn't sound right. Now, the thing is that the aesthetics of a theory is not dependent on the form you write the equation. It is based on the principle that underlies it. And if the principle that underlies it, in the case of GR, this principle of covariance, and so on, if it allows for the addition of the extra term, then that's fine. I mean, the aesthetic principle remains there, and the fact that you write it with a plus sign is meaningless. But Einstein somehow strongly disliked that.
And I loved what you did with Einstein in the book, because most people think of his biggest blunder, as Gamma put it, and you kind of disproved that notion. But most people think of his mistake as introducing the cosmological constant, and you go the other way around and say no, his mistake was taking it away after putting it.
Right. That's right.
And this has implications for today, right? With dark energy, and he could have predicted dark energy.
Predicted, exactly. Yes.
Yeah, and dark energy is a hot topic. You've worked this on a number of years in your scientific career, trying to understand what is going on with the universe and the acceleration of expansion. And there's really a lot we don't know, right? We have dark matter since the 70s and dark energy since the 90s, and we still don't have a good grasp on them. I was wondering if you could foresee that we can have a lot of brilliant blunders ahead of us in the history of science.
Oh, I'm sure we would have lots of brilliant blunders. I mean, the entire theory of string theory could turn out to be a brilliant blunder. I mean, there is no question it's brilliant. There is no question it introduced fantastic new mathematics, a whole host of wonderful concepts, but the theory may turn out, not to explain at the end of the day, the unification of general relativity and quantum mechanics. So that entire theory may turn out to be a brilliant blunder.
And is it not a little worrisome that so many physical concepts of today, such as string theory, are coming, in a way that they cannot be verified by experiment? I think we're flirting a lot with these notions that can't be, experimentally corroborated, such as multiverse and string theory. What do you feel about the path that physics is going forward?
Well, there is no question that this is a problem. So one of two things will happen. Either we will find ways to actually test these theories, which maybe we have not thought about yet, but we will find ways. And there are now ideas, how to try with actually relatively small experiments, tabletop experiments, to test some of these ideas, but by very, very careful measurements. Or, we will have to admit that maybe, not all of the things that we call laws of nature can be explained from first principles, and some of those things are random variables, that we have to live with. Like, a few hundred years ago, Kepler thought that the number of planets in the solar system has to be explained from first principles. And of course, we now know that that's an accident, how many planets you have in a system. So maybe we will discover that some of these things are really accidental variables and not things that come out of first principles. But, we still have a way to go. I mean, hopefully we will manage to generate some predictions.
And this, this that you touch upon is very related to the so-called anthropic principle. And
Correct.
you touch upon it on the book, but you do not make yourself clear in what is your position about it. Do you feel it's a satisfying concept, or something we should avoid at all costs?
No, I don't think we should avoid it at all costs. And I also don't think it is a satisfying concept. But I definitely don't think we should avoid it at all costs. I think that we should keep an open mind to the possibility that maybe some things are like that, are random variables, and so on. But of course, we should actually try to find explanations for all of them. But keeping an open mind to the possibility that maybe we will fail.
I see. And just to wrap this up, I hear you're releasing a new book in July in the United
Yes.
States called
Yes.
Why? What Makes Us Curious? I was wondering
Yes.
if you could just give us a sneak peek of what is coming out, what the book is about, what are you trying to achieve there?
Yes, I'll be happy to. So it's a book about human curiosity. As I think you can tell from my previous books, and this one, indeed, Brilliant Blunders, I am a very curious person myself. I've written about topics in mathematics, in the arts, in science, and so on. And so at one point I said, okay, but look, I know very little about human curiosity. I mean, why are people curious? What are they curious about? What are the mechanisms in the brains that make us curious? So in this book, Why, I tackle all of those subjects. Namely, I both describe the most recent experiments in psychology and in neuroscience that deal with the topic of curiosity. I also analyze two personalities of two people that I consider to be perhaps the most curious persons to have ever lived, namely Leonardo da Vinci and Richard Feynman. And I also interviewed 9 people that live today that I consider to be extraordinarily curious, trying to also understand what motivates them and so on. So I really tackled various aspects of human curiosity. And human curiosity, it's not an accident that the book is called Why, because animals are curious too at some level. But no animal other than humans actually asks the question why. Why is uniquely human. And so, that's the question I address. How did we come to this thing, and what happens in our brains to make us wonder why all the time?
In essence, why do we ask why? Right. Thank you very much, Professor Livio. It was a lively conversation. I thank you so much for taking the time to do this, and I hope we can talk again soon.
My pleasure.
É isso aí, essa foi a entrevista com o professor Mário Livio, espero que você tenha gostado e eu recomendo fortemente, eu já li, é muito bacana, Tolices Brilhantes, saiu pela editora Record aqui no Brasil, do professor Mário Livio. É isso, ficamos por aqui, mas em breve voltaremos com mais um Conexão Sideral. Até mais! Fui!